Now, if you go to your guided notes that I gave you, my first one is converting from degrees to radians, negative 405 degrees. The very first thing I need for you to do is to set the number they've given you into a fraction. We're going to multiply it by another fraction that's equivalent to 1, such that that degree symbol or label gets canceled. If you remember to multiplying, if I have a degree symbol in the numerator and a degree symbol in the denominator, it would cancel. And also within this fraction, what I'm converting into, which is radians. This has to be equal to 1, as in one circle. If I set it up by multiplying by 2 pi radians, and RAD is the abbreviation for that, over 360 degrees, each of these labels are equal to 1. My degree over my degree would cancel because a numerator and a denominator cancels out. And I would be left with my radian up in the top, and that is what I'm asked to turn into. In radians then, in your calculator, you ready in your calculator? You're going to put negative 405 times 2, leave the pi alone. So negative 405 times 2 divided by 360. Then hit the math key and do a math frac. That fraction that you're left with is negative 9/4. And the pi that I told you to leave alone and ignore gets popped onto the end of it. Negative 9/4 pi radians. So a little more quickly this one, on the next one, at 110 degrees, set it up as a fraction. Start with 110 degrees, put it over 1, multiply by a fraction that's equal to 1 circle over 1 circle. I want radians, so I put 2 pi radians up in the numerator. I'm getting rid of degrees, so I put 360 degrees in the denominator. My degree marks cancel, one top, one bottom. And in my calculator, I put 110 times 2 divided by 360. If you do a math frac on that, that gives you 11/18 pi, because we didn't put that in, it's still there, radians. That's your answer. To go the other way is very similar. Convert from radians into degrees. I start with the fraction that's already there, multiply it by a fraction that's equal to 1. Now, when there is no label, the radian goes up to the numerator, so that means I need my radian to be in the denominator. My 2 pi is my conversion, 2 pi radian, 360 degrees in the numerator, because it says here that I want to convert to degrees. Now you'll notice more cancels. Not just the radian label, but the pi cancels, the pi cancels. If you want, you could cancel the 360 and the 2, or the 360 with the 3, or double do it. Or you can just put in your calculator 5 times 360 and then divide it by 6. Remember, this is 3 times 2, so divide it by 6. Pi times 360 divided by 6. And you should get an answer of 300. 300 what? Degrees, because that was the label that we had left. One more time, negative 10 pi over 3. Remember, we multiply by a fraction. This is radians when it doesn't say up in the top, so we put radians down here. 2 pi radians is my conversion with 360 degrees. Radian cancels. Pi and pi cancel. And if you want, you could do 360 divided by 2, or 360 divided by 3, or 10 divided by 2. Doesn't matter. Put in your calculator negative 10 times 360 divided by 6. You get an answer of negative 600 degrees. So conversions aren't too bad if you remember to always multiply by this fraction that's equal to 1. Okay, today we're going to talk about converting between degree and radian measures. Let's talk about what that means. if I'm on an XY coordinate plane and I consider 1 unit being the radius, and remember that we start at 0 degrees right here, then as I go around this circle, remember back to our initial ray, terminal ray. The angle that it passes through, called theta, like you'd measure on a protractor, is in degrees. However, if we're on the same coordinate plane, and we talk about a circle with that unit 1 going around, excuse my drawing, that outer perimeter, the circumference of that circle, can be measured in what's called a radian, where the radius length, that unit 1, all the way around 1 unit would be the same as about this far along the circle, and that's called a radian, as in radius. 1 radian is an amount of the circumference equal to the radius length, which we're calling 1. So if you do the circumference 2 pi r around that circle, r is 1, then I know that there are 2 pi times 1 radians in a whole circle. I also know, because of what we've been talking about with degree measures, that there are 360 degrees on an initial ray, terminal ray rotation around that circle. So in degrees, I can say that there are 360 degrees in a whole circle. So we're going to use those 2 measurements. There are 2 pi radians in a circle. There are 360 degrees in a circle for converting.